Welcome back to Unit 2B, Section 2.8. You've learned how to write a chemical equation. You've learned how to balance and identify a chemical equation. Now what you're going to do is learn how to predict the products of a chemical reaction when only given reactants. To be successful in this section, you will need to use the reaction models found on the reference sheet. First thing you'll need to be able to do is identify the type of reaction. Then you're going to use your reference sheet to determine which model to use. You will create products for your reaction following the model as a guide. And as you form new ionic compounds, we want to always remember to check our charges to make our compound neutral. And we want to be able to recognize the elements of Brinkelhoff, all the diatomic elements of bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, and make sure that they're formatted correctly. And then, of course, balance the chemical equation. So in front of you is a copy of the guidelines that you will need to follow using your reference sheet. In this particular section, we will only focus in on the synthesis and decomposition models. So the first model that we will look at under synthesis reaction is 1A, and that is the formation of a binary ionic compound. You will notice that on the left, the reactants are two elements, in this case a metal and a nonmetal, and they will form a single product, which is the binary ionic compound. So how do you predict this portion right here? What you will do is you will bring the symbols together of the two elements, and then you will check your charges. So if we take a look at this first example, we will just bring the K and the Br next to each other, and then we will check our charges. Now, off to the right, I'm going to do this, and you should be very comfortable with this by now. +1 and a -1 will neutralize out, and so the answer really is KBr. Now we're going to balance, and so I notice that I have 2 bromine, so I'm going to put a 2 in front of the KBr. That then gives me 2 potassium, so I'm going to end up putting a 2 over here as well, and now my reaction is balanced. The second model under synthesis is model 1B. It is when the metal oxide will react with water to form a base. If we take a look at the reactants, you will notice that instead of the last example where there were 2 elements, you actually have 2 compounds, but they will form one single compound. In this case, a metal hydroxide, which by now you guys know as a base. So how do we do this? Well, first thing you have to recognize is the metal oxide reacting with the water. And then what you'll do is you'll find the metal, in this case it's calcium, and you'll place it next to the hydroxide, and then you will check your charges. So off to the side, I'm going to go ahead and do that. You should be really good at this step by now. We're going to crisscross those numbers down, and that's going to give me Ca parentheses OH close parentheses 2. Upon closer inspection, I will notice that this is already balanced, and so I don't have to do anything else to this. We are finished with this one. Model 1C is also another example of a compound and a compound reacting to form a single compound. In this case, we're going to be looking at a nonmetal oxide and water, and we're going to be forming an oxyacid. Right above that word, oxyacid, I do have the skeletal structure of an oxyacid. Remember, there will be a hydrogen sitting in front, some nonmetal in a particular ratio with oxygen. So how do we predict the products of this oxyacid? The first thing that we need to do is look over at the reactant atoms. We're just going to count them all up, starting with the hydrogen, then the nonmetal, ending with the oxygen. Sometimes you need to simplify, but for you in this class, you generally won't have to do that. So in this case, I've got 2 hydrogens, so I'm going to write H2. I've got 1 carbon, keep that as 1, and I've got 2 plus 1 is 3 oxygen. And you now see that I am finished with this reaction. Because I counted up all the atoms, it is also already going to be balanced. Now we're going to look at decomposition reactions. There are 6 models, and we're going to focus in on the first one, which is model 2A. It is going to be the breakdown of a binary compound. You'll notice that this is very similar to the first one that we did under synthesis. It's just the reverse process. Notice that we're starting off with a single compound, and we'll be breaking that apart into the 2 elements that make it up. Right? And we want to be very careful about recognizing a diatomic element. Remember that it will not exist as a single atom, but two atoms. And the acronym or mnemonic for that is Brinkelhoff. All right, so in this example right here, I see just a single substance. I know this is a decomposition reaction. I see that it is binary, consisting of only two element symbols, and so I'm just going to simply split it apart into the calcium and the chlorine element. I do recognize that chlorine is part of the diatomic series, so I will put a 2 down there. Please understand that that 2 is not there because of this 2 right here. It is because chlorine is a diatomic element when by itself. So in this case right here, we are finished predicting this, and it is already balanced as well. Model 2b is another decomposition reaction. We're going to start off with the single compound. We're going to identify it as a metal carbonate. And metal carbonates always break down into metal oxides and carbon dioxide gas. So how are we going to predict these products? Well, you're going to find the metal in the compound, and you're going to place it next to oxygen. You will check your charges because you've just formed an ionic compound, and then you will add carbon dioxide to the other side, to the product side. So if we take a look at our example, I recognize this as a metal carbonate. I'm going to find my metal, which is just K. Remember, we never take subscripts when we're doing this. We're only taking symbols. And we're going to then add that to the O. Of course, off to the side, I'm going to check my charges and realize that this formula is really K2O. And then I'm just going to add that CO2. And then I need to balance it, but upon closer inspection, once again, we'll notice that this is already balanced. So we can just leave it as is. Okay, the third decomposition reaction is Model 2C. It is a metal hydrogen carbonate or bicarbonate decomposing into a metal oxide, water, and carbon dioxide. So how do we predict those products? Well, we have to go back and identify our single reactant as a metal bicarbonate. And then what we do is we take that metal and we place it next to oxygen and check our charges. And then we're going to add water and carbon dioxide. So if we come down to our example, I will notice that this is a metal bicarbonate, and my metal is sodium. So I'm going to go ahead and put an Na next to the O. Off to the far right, I'm going to go ahead and I'm going to check my charges and realize that this needs to be Na2O. And then I'm just going to add the H2O and the CO2 as the other two products. I do need to balance this, and I will realize that there are two sodiums over here, so I need to put a 2 on the left. That will then give me 2 hydrogen, which I have over here, 2 carbon, which I don't have, so I'm going to go ahead and add another 2 here, and then it will give me 6 hydrogen, and I have 1 and another 1, which is 2, and then 4, which will give me 6. So here we see the final result. All right, the next one is Model 2D. This is going to be a metal hydroxide breaking down into a metal oxide and water. How do we predict these? We need to first identify that we have a metal hydroxide as our single reactant, identify our metal, and this time we're going to put it next to oxygen. And then we're going to check our charges, and then I'm going to add water. So down here I recognize this is a metal hydroxide. My metal is lithium, so I'm going to put that next to the oxygen. I'm going to check my charges and do the crisscross to get the correct ratios, and then I'm just going to add H2O. All right, now I need to balance this. So I notice that I have 2 lithium on the right. So I'm going to put a 2 here. That will then give me 2 oxygen. And I have 1, and 1 is 2 oxygen, and 2 hydrogen. I have 2 hydrogen on the other side as well. And this is now balanced. And our last reaction in this decomposition set is Model 2E, metal chlorates. So the metal chlorate will break down into a metal chloride and oxygen. How do we come up with these products? We're going to identify the metal chlorate as the single reactant, find the metal. We're going to place it next to chlorine, check our charges, and this time we will add oxygen gas. We go down to the example. There's my metal chlorate, there's my metal. I'm going to go ahead and put that next to chlorine. Off to the side, I will check my charges. They are fine in a 1-to-1 ratio, and then I will add O2. I do need to balance this chemical equation, and so as I look over to the right, I notice that there are 2 oxygens and 3 oxygens on the left. I'm going to find my lowest common multiple of 6. That will allow me to put a 3 here and a 2 here to get 6 oxygen, and that changes my silver and chlorine to 2 as well, and so I will put a 2 in front of AgCl, and that will clear up this last reaction, and it is now balanced. So one of the things I just want to remind you of when doing this is that the reference sheet provides the models, and they basically tell you what to do. Okay, so you just need to follow the patterns, and once again, as always, the more practice that you do, the better you're going to become with this. Stay tuned for the next set of reactions where I will introduce single replacement, double replacement, and combustion. Have a great day.